Hello everyone, and welcome to the NEATEC Electronics Series. This video is about shift registers, so let's get started. Hello everyone. Today we're going to talk about shift registers, and specifically three types, okay? One, we're going to have this talk about the serial, which is what we have. We're going to draw it down below here in just a second. Two, we're going to talk about parallel. And third, we're going to talk about rotation. All right? And we're going to do these in order. So to get some space, I'm going to get rid of that for now. Let's talk about a shift register. And what I've done is I've drawn 4 D flip-flops here from right to left, as you can see. So we have the D, the Q, and the clock. This is the clock for each one of these, all right? Now, I'm going to do a little label here. Okay. So, let's make this one a shift right. We're going to do both types, a shift left and a shift right. We're going to go over both types, okay? So I want to make sure that you understand this one. Okay, so first, with these serial shift registers that I'm going to draw you, all of the clocks are connected together, okay? So there's your clock pulse, all right? They're all connected together, all right? I used red for that, like you're using a red wire, for example, on your breadboard, okay, in the lab. Now, if you remember, we're going to give each of these a name, okay? So let's call this 3, this one 2, this one 1, and this one's 0, okay? Remember, Q is your output. So if we're going left to right, this is an output here. This is going to be Q0, and this is your output. Got it? Now here, this one's going to be right there. This one right there, that's simply going to be Q1, isn't it? Now, let's just continue this method for the rest of them, okay? There's Q2, and there's Q3. All right? Now remember, a flip-flop, the output Q can either be a 1 or a 0. All right? Now here's the thing, okay, about a serial register. One bit, depending which way you're shifting, obviously, but one bit has to feed another bit. Since it's shifting right, all right, Q3 is going to connect to the input of the second flip-flop. Q2 is going to connect to the first one. Q1 is going to connect to 0. By the way, I look like that should be a 0. It's not a Q there. Okay? So if we start out, suppose we have this here. This is Q0, Q1, Q2, Q3. Now, if we start with all of them as zeros, right? By the way, each one of these flip-flops has a preset and clear, right? I didn't draw them because I'm trying to keep the circuit rather straightforward here, but they all have the preset and clear. You use those so you can start up in a defined state. Anyway, that's what you would use to start it all up at 0, for example, like I drew here. And then suppose you have an input. By the way, we didn't draw that. Where's your input? This is your serial in, right? Now suppose you clock it, okay? That means Q3 is now going to be a 1, right? Because that's what's feeding it. Q2 is going to be a 0 because Q3 fed Q2. Q1 is going to be a 0 because Q2 fed Q1. Q0 is going to be a 0 because Q1 fed Q0, right? Now, suppose your serial input now is not a 1, it's just going to be zeros from now on. So if you clock it, what's going to happen next? Well, you're going to clock in a 0. This 1 is going to move over here, right, to Q2. Well, this is going to shift to the right, so that's going to be a 0, and that's going to be a 0. Get it? Again, serial in is going to be 0 from now on. You clock it, what's going to happen? Then you clock it. Then clock it. You just flushed your register, didn't you? Now it's all 0. You understand the 1 is moving to the right for every clock. That's why you call it a serial shift right register. Okay? Next we're going to draw a serial shift left register. See you in a minute. Alright, so now we're going to start making a serial shift left register. Okay? So I kept some of our prior circuit. For example, the clock. I kept the clock connected to each clock input because that stays the same. Alright? So I have erased much of everything else. Okay? So as you can see, I moved the serial in over here on the right because it's going to be shifting to the left, right? It's going to be going that way, okay? So just think about it. What is the input to a flip-flop? It's on the D, right? Let me get rid of this here. This shouldn't be here. So really, how this needs to be done, I'm just going to move the serial in up there, that's all, okay? So let's just think about this. Here's your input. It's going to be there's your serial in. It's coming right there. Okay, that's your input. Okay. Now, I'm going to draw these in colors to try to keep them pretty straight, right? So if that's your input, you know your output is Q, right? So let's take Q, come up here. We're going to come into another input, don't we? There we go, right? So what was in 0, what was in this one right here, right? As you can see, what was in 0, it's going to now go into 1. Now let's change colors. Let's go from 1 into 2. Think about how you would do that. Well, there you go, right? So what was in 1 is now going to go out and go into 2, isn't it? Now let's do the third one here. Let's use orange, okay? See if you can draw this yourself while I'm drawing it, okay? So the output is Q, obviously. We're going to come here. Into D, right? Beautiful. Now, and then here are your outputs. So let's draw your outputs right here, shall we? Here is this is Q3, right? Here is Q2. Here is Q1. And here Q0, right? The reason why these dots are there is I'm drawing this in line mode and I have to deselect it. Seems to be a convenient way of doing it. So let's just draw this now, right? This is what, Q3, Q2, Q1, here's Q0, right? Now let's do this over here, shall we? 0, Q1, Q2, Q3. Now suppose we're starting at a 0, 0, 0, 0 state, right? Now, let's clock it, and we're going to clock a 1 in, a high bit, right? So you can see, I'm going to draw this in light blue, okay? So this 1 is going to come down here. It's going to be clocked in, okay? So that's going to be a 1. Now, what was in Q0 is now going to go in Q1, right? Because here's your output. Just follow this green line all the way. Now it goes to the input, and that's Q1, right? So that's going to be a 0, isn't it? Now you can use the same thing for the same logic for this one. Your output from Q1 is going to come up here, going to go down these, right down in here, right? going to be a 0. And the same thing for Q3. All right? Just follow the orange all the way around, okay? Now suppose the rest of the serial in coming from up here, they're all zeros. So you clock it again, right? You clock it once, one clock pulse. What's going to happen? Well, you're going to have a 0 coming in. That's what we just said. The 1 is going to populate to Q1. What was in Q1 is going to go to Q2. What was in Q2 is going to go to Q3. And it just progressed, right? It's progressing to the left, as you can see. Clock it again. 0, 0, 1, 0. Clock it again. 0, 0, 0, 1. Clock it again. 0, 0, 0, 0. You see, as you went through this, the 1 shifted to the left. That's why they call it a shift left. All right? All right, everyone. See you in a minute. All right, everyone. So now what I have drawn for you here is a ring counter. Okay? Specifically, this is a 4-bit ring counter because there's 4 bits, right? So let's follow it, shall we? Suppose we start in a state like this, all right, where Q3 is equal to 1 and everything else is 0, right? And then we clock it. What's going to happen? Well, if you notice, what's in 0 goes out, goes all the way around here, and comes back into 3, doesn't it? So specifically, since Q0 was 0, Q3 is going to be 0. Now for all the rest of the bits, they're just going to shift to the right. You see that? So that would be 1, 0, 0. Get it? Now we clock it again. What would happen? 0, 0, 1, 0. Get it? We clock it again. 0, 0, 0, 1. Finally, we clock it one more time. What's going to happen? It's going to come back to its starting value, right? It's a ring counter. And for a ring counter, I'm going to write this down to make sure that you remember it. So for a ring counter, Q, right, is connected back to D0. Or in this case, I'm sorry, it's not D. It's going to, for a 4-bit, it's going to be D3. It's going to be Q0 is connected to D3 for the 4-bit ring counter, okay? Now, I'm going to give you a twist here. We're going to change this. It's no longer a ring counter, okay? And we're going to make one small change here. That's Q bar, okay? So I'm going to just draw this a little differently for you so it would help you remember it. So this is for a ring counter, okay? I'm going to take this one and just move it over here. You know that. Now, what I've just drawn for you here is called the Johnson counter. Alright? So this is different. Okay? As you can see, it's obviously it's going to be different because it's a different circuit. Now, for a Johnson, and that's a 4-bit, by the way. I think you all know that anyway. 4-bit ring, right? Now, we'll do a 4-bit Johnson counter. So let's start them all at 0. Now, what's going to happen when you clock it? Well, if they're all 0 and you clock it, Q0 is going to output Q bar. Q bar is what's going to go on to the 3, right? So when you clock it, it's going to output the complement of Q, which is Q bar. So instead of passing the 0, it's going to pass a 1, right? So a 1 is going to go all the way to Q3. So specifically, that's going to be a 1, 0, 0, 0. Now you clock it again. Clock it again. Clock it again. Now, look what you've done. You've completely changed it from all 0s to all 1s, right? Now, clock it again. What are you going to get? Clock it again. Clock it again. And one more time, clock it again. You're back to the beginning, aren't you? So as you can see, for the Johnson counter, you have 8 unique states, right? Now, all from changing that Q to a Q bar, right? So let me just write this down, the specifics for this one. So for a 4-bit Johnson, so what do we connect? It's going to be Q0 bar is connected to D3. Get it? That's what we just did. Now, basically, what I have told you are the basics for shift registers. You have a serial shift register, you have a parallel shift register, and then you have these rotational or ring type of counters, okay? Now, it is possible to combine these counters using specific circuits, but now you understand the basics of what each register is, all right? All right, everyone, I hope this has helped you, and I will see you again soon. Bye now.